Hello students, welcome to Educate. We are going to continue with the chapter Gravitation of class 11th Physics. So in previous lecture we have studied about escape velocity, orbital velocity and potential energy. Now we are continuing with the same concept. So here there is application of those concepts. Here question says, weighing the earth. You are given the following data: G equal to 9.81 meter per second square, RE equal to 6.37 into 10 power 6 meter, the distance of the moon R equal to 3.84 into 10 power 8 meter, and the time period of the moon's revolution is 27.3 days. Obtain the mass of the earth ME in two different ways. So there are two ways. One, by using the concept G is gm upon r square. So m can be found by gr square divided by capital G. We put the values. So 9.81 into r is given as 6.37 into 10 power 6. So 6.37 into 10 power 6 whole square divided by value of G 6.67 into 10 to the power minus 11. If you evaluate it, it will give around 5.97 into 10 to the power 24 kg. So this is one method. Another method in which Kepler's laws are used. So we have already studied about it. Let's recall it. So if you remember, here in this case we can apply gravitational force, say it is Fg, Gm, m, here m is mass of moon we are taking, and this is mass of earth, divided by r square must be equal to centripetal force. So mv divided by mv square divided by r. Now v equal to 2 pi r divided by time period. So we can put that value here, mm will get cancelled. So gm divided by r square equal to 1 r you can cancel from here. So just write r. This r will get cancelled. Here it will become 4 pi r square, 4 pi square r square in place of v, and divide by t square, right? And now this r will get multiplied to it, so this will become r cube, and t square will remain here. Our concern is to get m, so we can retain m here, and we write 4 pi square divided by g times r cube. This r will get multiplied to r square r cube divided by t square. So this is the relation that we are going to make use. 4 pi square r cube divided by g times t square. Now we can put the values. 4 into 9.8, sorry, pi will be 3.14 whole square into r is given as 3.84 into 10 to the power 8. Then you can make it cube, and g is 6.67 into 10 to the power minus 11. Time period is given as 27.3 days. So 27.3 days means days 24 hours into 60 into 60, and we can put these values here. And after that, if we evaluate, it comes out to be around 6.02 into 10 power 24 kg. In previous case it was around 5.97 into 10 power 24 kg, and in this case it is this much. So almost both values are same. Now next concept is energy of an orbiting satellite. But before that, there is one more question. Let's see this question. Here they are saying, express the constant k of equation 7.38 in days and kilometers given k equal to this much. The moon is at distance this much from the earth. Obtain its time period of revolution in days. So here value of k is given. They are saying that you have to express k in terms of days. second is to be converted into a, and meter is to be replaced by kilometer. So it is simple. So let's evaluate it. So value of k is given as it is 10 power minus 13 second square meter power minus 1. 10 power minus 13 second square and meter power minus 3. Meter power minus 3. So what we can do now, second is to be converted to days, meter is to be converted to kilometer. So very simple, you do 3600. Second means 1 hour into 24 is 1 day. Second equal to 1 day. So 1 second will be 1 upon 3600 into 24 days. So here you will write that, and then next point is 1000 meter equal to 1 kilometer. So you can write 1 meter is 10 power minus 3 kilometer, and put these values here and simplify. So after that, after simplification, you will get 1.33 into 10 power minus 14, then day square kilometer power minus 3. So it is not tough, you can do. And then we have to find out t square, means time period is to be found. So time period can easily be found. Here they are saying that you have to use 7.38 equation. So let's see first equation. So here 7.38 equation is 2 pi t0 equal to 2 pi root re upon g. So we can put the value of re, distance is given, g value of g, and we can get. So only change that is needed here is, so you have to find out t, that is 2 pi times root re upon g, small g. So values are given, and this distance 3.84 into 10 to the power 8 meter is given. We put those values, so the value of g and pi, and after putting that value we will get it as 27.3 days. So the same thing is shown here. If you observe it, so you will see here it's a given, so you can easily evaluate. And then comes energy of an orbiting satellite. So you know that orbital velocity we have just calculated. So orbital velocity was gm divided by r plus h under root. So this was orbital velocity. So if we want to find out kinetic energy, so then we can write mass and then velocity squared. So we will get this relation. So g 1 by 2 mv square, and here m. So your velocity can be, orbital velocity can be squared. When we square it, so it will become gm upon r plus h whole square. So root sign will be removed. So we will get this relation. Now, if we consider potential energy, so potential energy, if you remember, potential energy is given by, we have got kinetic energy, right, after writing this value, and that is equal to G small m capital M divided by twice of R plus H, right. If we consider potential energy, it will be negative G M capital M small m divided by just R plus H, right? If you find total energy will be negative. So here total energy will be equal to Gm capital M divided by twice of R plus H and minus Gmm divided by R plus H, right? So it will become minus Gmm divided by twice of R plus H, right? So we have got total energy negative. Why? Because forces of attractive nature. Now there is another question. The question says a 400 kg satellite is in circular orbit of radius 2 RE about the Earth. How much energy is required to transfer it to a circular orbit of radius 4 RE? What are the changes in the kinetic and potential energies? So in the two cases, we are going to calculate the energies. So here, initial energy can be calculated. So it will be, first it is given a 400 kg satellite is in circular orbit of radius 2 RE, right? And then it is shifted to another orbit of radius 4 RE. And if you remember, total energy is given by minus Gmm divided by twice of R plus H. Here just write as RE. So initial energy can be written as minus Gme and just Me and M divided by twice of, say, we write it, but here this is given twice of radius, so 2, so just write it Re and you multiply by 2, and then it is 4E, so 1 by 2 is already there, you know, so E final you can write as minus Gme M small m divided by 2 is already there, then 4 Re. In previous case it was 2 Re, here sorry, so it will become 8 Re. Now we find the difference. So difference can be found. So difference will be E final minus E initial. So E final minus E initial will be how much? It will come out to be 1 upon 8 times Gme small m divided by, here this is Re by mistake, so this is Re. Now here if we want to introduce small g, so R square we need, so we can multiply here Re and here we multiply by Re. So this portion will become small g. So we can say it is equal to 1 by 8 times small g into small m into Re, right? And then we can put the values. So after putting values, we will get 3.13 into 10 to the power how much? 9 joule, right? This all is given here. Now we can say that kinetic energy is reduced and it mimics delta E, obviously. So delta kinetic will be K final minus K initial, so that will come out to be 3.13 to 10 power 9 joule. The change in potential energy is twice the change in the total energy. So the question is simple. I think you have understood. Now question, all questions are done, and if you want to have a recollection, so we can just recall. We started from first thing is mv square upon r, which is centripetal force, and there we equated like g m divided by r square. This was one concept. Another concept was value of small g at height h. So in that case, we got g times 1 minus 2h upon r, and value of g at depth d, that was g 1 minus d upon r. Then we evaluated v orbital, so that is equal to root gr, which was about 7.92 kilometer per second. Then we found v escape, that is 2gr, and it was 11.2 kilometer per second. And then we derived potential energy PE, that is minus gm1 m2 divided by r. Later on, delta U we found as mgh. Then we evaluated this potential V minus gm divided by r. After that, we found total energy, kinetic energy 1 by 2, and here recently we evaluated it 1 by 2 gm divided by r plus h, and here 1 m is more, and the potential energy we got as minus gm m divided by r plus h. Then we evaluated total energy. Total energy will be total energy as minus gm m divided by twice of r plus h. So these are the basic concepts of gravitation, and I think you have understood them properly. We will do numericals in next lecture. Thank you for watching. Team Educate.